The last example I'm going to do is problem number 8 from page 213. And we have an equation, and it is impossible for us to isolate y in this. There's no way we're going to do this. So our only course of action is to use implicit differentiation. So I'm going to plow right across, and I'm going to take the derivative with regard to x of everything I encounter. And the first thing that I hit is something that only has an x in it. So the derivative of that is straightforward. The derivative of 2x to the third is going to be 6x squared. But when I come to my next term, now I have, in fact, two different functions. I have this x squared, and then I have y, which I need to assume is some function of x. So since I have two different functions, I just have to use the product rule here. So I'll talk through that. So the derivative of the first part, the derivative of the 2x is, of x squared is 2x. So I have the derivative of the first times the second plus the first times the derivative of the second, which is dy dx. Moving along, I have the same situation with this xy to the third. I know I need to use the product rule, and so I'm going to put this in parentheses so I don't lose, just lose something here. So derivative of the first is 1 times the second plus the first times the derivative of the second. And the derivative of the second here is going to be 3 y squared times dy dx. And on the right-hand side, the derivative of 2 is just 0. So now our task is to isolate the dy dx. So our task is to isolate, Our task is to isolate dy dx there and there. So I'm going to move, I'm going to distribute the negative. So I have 6x squared plus 2xy plus x squared dy dx minus y cubed minus 3x y squared dy dx is equal to 0. I need to isolate these two things. So I'm going to move everything else to the other side. Okay, so I end up with x squared dy dx minus 3x y squared dy dx is going to be equal to, let's see, I'm going to have a y to the third on the other side, minus 2xy minus 6x squared. And all I need to do is factor out the dy dx. So I'm factoring out dy dx, and I will be left with x squared minus 3xy squared. And on the other side, we'll still have y cubed minus 2xy minus 6x squared. And I just, again, still need to isolate dy dx. So I am just going to divide by the x squared minus 3xy squared. So dy dx, then our derivative is y to the third minus 2xy minus 6x squared all over x squared minus 3xy squared. And that is my derivative. Whoever thought we'd get there?